This one is about files or streams as they are considered inside of C++. It's a weird word, I know, but we're used to it together. I think this could be slightly bigger. There it goes. And this is going to be a very easy set of slides. We have learned a lot of hard things, and you needed to learn them before so that they could stay in your mind and just churn for a while. And now this is going to be very nice and easy, a breath of fresh air. Okay, files and streams are not hard. You could have learned this weeks ago. So it is great. Let's talk about it. Let's make a program that writes to a file. Why not? That'll be fun. The type of things that we're going to use to make this happen is called OFStream. Okay, and it's going to give us a way to add stuff to a file, to create a brand new file and write to it. Okay, and this is another way to give output, isn't it? So right now we have just one way of giving output back to the user. You can see out something, right? That's the only way that we have right now to give information back to the user. You can say cout 42 or whatever, and then it appears on their screen. That is the one way we know how to give output back to the user, right? Let's do something else. OFStream is a kind of type. There's a library we'll have to include to get it, but it's a type that will write to a file, all right? It's short for output file stream. That's the name, all right? But if you make this OFStream thing, this OFStream object, and you give it the name of a file you'd like to write to, you start giving it information, it will write to that file. All right, so the library where it lives is called FStream, and OFStream stands for output file stream. And the second you make one of those objects, you say OFStream, give it a name, like OFS or something. And then eventually you have to give it the name of the file you want to open. But you can start giving it stuff, OFS, you can start giving it 42 or whatever, just like you could have given to cout. So that same arrow operator works for OFStreams, right? So let's look at that documentation page where it lives. It is here, input, output, FStream, and yeah, we're going to use OFStream. And you can click some of these to kind of understand what's going to happen, but this operator exists. It's going to work just like cout. We can open files. We can start writing stuff to files. This is kind of how it's going to work. Open a file, give it information, close the file, right? That's going to be the goal. So for example, let's write 1 to 10 into a file, right? A file with the name of our choosing. We'll call it 1 to 10.txt for a text file. But what we're going to do is fill this file. We're going to write a program that creates and fills this file with 1, 2, 3, all the way to 10. Right? Instead of printing it to the screen, we're going to print to a file, right? That's beautiful. New stuff. So yeah, we'll include this new library. We're going to make an OFStream object and then set which file it's going to open. All right? So I'll make a new C++ file. I'll call it 1 to 10.cpp. And running this program is going to write to a brand new file. Right? So I want to include FStream. And the first step is to make an OFStream object. OFStream, give it some name. I like to call it usually just OFS, like output file stream. A stream, by the way, is like C++'s word for a file. It's like, think of a file as just like a stream of ones and zeros floating on the river. Okay, it's kind of the idea. A stream of characters that you can read to, write from. So yeah, we have to make an OFStream object. So we have something to hook into this file. So we're going to declare the object. First step, done. And then we have to open the file that we want to write to. Right? So we give a file name as a string that we want to open. And I'll just make one in my current directory. So I'll just give the name of the file. So ofs.open. That's a method on the OFS class. And you give the name of the file that you'd like to have opened for you. So we'll call it 1 to 10.txt. All right, so after that's done, it's got the file open. It will make it if it doesn't already exist. And then we just pretend, all right? Then we pretend to output to it like as if it were cout. All right, so we write to it just like as if it were cout, and then we close the file with the close method. That's it. All right, so let's make this happen. So for int I equals 1, I is less than or equal to 10, right? I plus plus. Not instead of cout I and a new line, give it to the OFS. That's the difference. Give it to the file. All right, And then once you're done, it's always good to say ofs.close, even though your files are going to get closed as your program ends. This is good practice for when you make longer running programs. It's good practice to close the file as soon as you're done working on it. Because then other programs that might want to see this file and write to it some more can see it after that. Like the operating system puts a lock on the file once you own it and are working on it. The second you close it, other people can use it. Other programs. Okay? So yeah, that's the idea. G++, not too bad. This is going to be a program that produces no output to the terminal when I run it. Nothing happened. But secretly, it made the new file. See it? It didn't exist already. Let me prove that to you. Let me remove the file, the text file. It's not there. Rerun the program. /10. Bam, it's there now. Isn't that cool? And then we can look at it. We can look at it in Vim. There it is. We did it. 10 separate lines, 1 through 10 in that file only. Any questions about this? Isn't that fun? Yeah. Yes, so we made a program. We've been writing programs this whole class, right? This is a program that creates a file and writes to it. Oh, where did I? Oh, thank you. Thank you, yes. All right. Now we all. So that's what we want to do. That's how you can write to a file. You can put whatever you want in it. All right. Another way that you could have done it is you can open the file in 2 different ways. You can do the open method, like I did, after you've made the object. So that was this one. Say .open, give it the name of a file. Or you could have used the constructor. The constructor, it has a default constructor and then a parameterized one. The parameterized one will take the file that you would like to open. Okay, so that could have been something you did as well. So alternatively, I could have done it like this. Instead of those 2 lines, I could have done this line. I could have said ofstream, ofs, and into its constructor.txt. All right, so that would have done the equivalent of these 2 lines all at once. Okay, so these 2 lines are equivalent to the above. All right, so you have options. All right, so dun. That's the goal. That's writing from 1 to 10. Not too horrible, right? An easy topic finally. So it's always good to close that file, even though it's going to be closed for you at the end of the scope. All right, which is the nearest closing curly brace, and I'll try to make this prettier. That guy. So technically the file will be closed automatically for you by the time you get here, but it's always good practice to do it yourself, because just in case you make the file on the heap one day, it doesn't actually go away. Okay, so that's going to be the goal. So it's always good to do that. And yeah, what do you think happens if I rerun this program 1 to 10? I mean, the file already existed. What if I run it 10 times? What do we think happens? What's going to go on in the file? A bunch of times? Yeah, let's see. It's still 1 to 10. So it's overwriting. Every time you open this file, it is if it already exists, it's deleting it technically, and then it's overwriting it with brand new information every time you run it right now. Okay? So sometimes that's not what you want. Okay? So if I rerun that program, right, it's going to overwrite the contents. They keep getting replaced. But sometimes we just want to whatever's there, keep it there. We're creating a log of stuff. We'd like to just add to the end, and that's called appending. We'd like to append to the file. Okay? And so the way that you can append instead of overwrite is you open up your file in a special mode, we say. So actually the constructor as well as, so it's taking a mode here, the constructor as well as the open method took which mode, and by default it was overwrite. We can change that. Okay? We can change that, and we'll pass iOS_base::app. That's a very long word, but that's what we need here. Right? If we open up in that mode, it will append to the file. All right, so we'll say it like this. We'll say ofs.open. We'll give the file name again, and then we don't want the default overwrite mode. We want iOS underscore base colon app mode, please. Okay, so that's what you do. And then the second you do that, you can write to OFS, give it stuff like 11, and it will keep what was there before, right? You'll have your 1 through 10 still, all the way to 10, and it will add that new thing at the end, 11. Okay, so that's the trick, right? That's appending. Let me show you that. I guess I want to copy most of this file. Append.cpp. So let's do it this way again. And so instead of the default, open it up and overwrite, open it up in this way, iOS base app mode, append mode. And so now when I write to it, I'll just give it the one line, I'll say 11 or something. Then it'll keep what was there and add 11 to the end. Okay, let's open it up in appending mode. So let's create this program, compile it. And then here's the file. Let's just watch it not get clobbered. So I say ./append. I'm still opening up that file, right? And I'm opening it up in append mode. So I run it once. I tell them to refresh itself. Not overwrite it. And if I rerun it a few times, I got a few more 11s sitting there. There they are. Every time you run it, it adds it. Okay? It adds a single line. Does that make enough sense? That's just a different way of opening the file. And so if you want to keep stuff, you open it up in append mode. Let's see here. Accidentally closed what I was looking at. Yeah, so that's another thing. And it might be kind of cool, right? It's pretty fancy that like you're using the same operator. You're pretending like you're just replacing cout with the name of the file. There is something deeper there that I want to go into now. Question first? No, yeah, the mode is like the name of the parameter. It's the kind of, it's the mode in which you would like to open the file. So this is what this parameter means. It's the mode I want to open the file. So this is a constant thing that we're passing along to mean append. Yeah. So no mode, just this thing. It's just like a number or something. It's like 42 means append, 41 means overwrite. It's doing something like that. Yeah. Let's see here. So yeah, let's get into that. Like, why in the world do I get in an OF stream this operator? Because that's very similar, right? It's very similar to what cout was doing. I get that same idea of being able to give it stuff. So it has to do with the types. I'm very excited to teach to you this. We've never actually considered the type of cout before, have we? Like, what is it? It's not an int, right? It's not a bool. Its actual type is called ostream. Alright, so cout's type is an ostream. Type is an ostream. That's kind of what I mean by that. And OF stream, it also is an ostream, even though this is its normal type. It has like a inner type as well, place that it's taking stuff from. It inherits from ostream, we say. Alright, so ostream is just another type. And watch. IOStream, right, is where cout lives. Let me prove to you that its type is ostream. So cout, click on it. Look at it right there. It's a little small, but ostream is the type of cout. All right, what is ostream? I can click on ostream. What does that give us? What can you do to an ostream? Every one of them can have stuff shoved into them with that operator. That's the trick. That's why they both work in the same way. Isn't that cool? And so yeah, ostream is just another type. And OF stream, even though that's its normal name of its type, it inherits from, we say, ostream. And you'll learn more about that in CSCI 41. But if I go back to OF stream and I turn off my dark mode, you see this little diagram of type, where the types are coming from. So OF stream is the name of the real type, but it's inheriting from ostream, which is itself inheriting from iOS. These are all inner, basic, more simpler types that it's taken stuff from. So every OF stream can be treated like an ostream because it's being derived from it, we say. Right? So it's got everything from ostream in it. And you see that here. Public member functions inherited from ostream. That's why it has it. Isn't that neat? All right? This is very complicated stuff, but you will learn more about it later, one day. But that's all we need to know right now. OF stream, it has, like it's the child of ostream. It's everything an ostream has, but some extra stuff added. Okay? So that's why. Because they are both related in type, they both have O streams somewhere, cout and every file you make, every OF stream you make, they're going to work in the same way. All right? So that means they get this operator in addition to other things. Like they get these little things that you can click on and figure out what they mean. I'm not going to teach you. So that's the moral of this story. That's why cout, you can say give to cout stuff and give to your file stream stuff. All right? So with that in mind, let me do something cool. Let me write a function that takes as a parameter an OStream. Because then I could pass, because cout's an OStream, files are OStreams, I could pass either a file or cout to this function. Won't that be cool? Watch. I'll do it like this. I'll take an OStream, it's got to be by reference, and I'll make this function called write 1 to 10. It'll take this OStream, whichever one I give. I can give cout, I can give a file, and I will just like give it stuff, give whatever OS was stuff, and it will write 1 to 10 to it. Won't that be fun? Because I can call it like this. I can give it a file, because every file is an OStream. Or I could give it cout, and then it will write 1 to 10 to the terminal. Isn't that great? I love this idea. So it's really cool. Let's watch it work. All right. So let's do that. I'll call it this file. OStreams. All right. So let's do one. I guess I want to steal this 1 to 10 stuff. I got most of the code there, right? So watch. We'll make a function called this. Write 1 to 10 that takes an OStream as a parameter. Won't that be fun? And what it does is whatever that OStream was, we're calling it OS. OS. We know that for every OStream you can give it stuff, so we'll give it stuff. And this is writing 1 to 10 to the OStream, whatever it was. Does that make sense so far? And now I can pass things that are OStreams. Watch. So let's see here. Let's do. I can pass an OF stream for sure. I can say this, right? I can say write 1 to 10 and give it OFS, because every OF stream is an O stream. I can do it that way. Or I also know that cout is an O stream. I can give it cout as an argument. That's the type, right? Both of these will work. Any questions about that? Constant that the getLine function uses to give like you can getLine and cin. You pass cin to getLine, and so it needed to know its type. Yeah, cin's type, as you might expect, is iStream. Yeah, so it did something like that when somebody, like the library implementers, were making getLine. That's exactly right. Yeah. They know its type too. So, okay, let's compile and run this. Let's see if I can give you the relevant code. I might have to zoom in a little bit. There. G++ OStreams -O OStreams. So, you know that the file, right, 1 to 10.txt holds a bunch of lines with 11 on it. This is not opening in append mode. It's going to overwrite it when it works, right? It's going to overwrite it. When I run this, OStreams, so not only did it mess with the file, overwrote it back to 1 to 10, that was this call. OFS was shoved into OS, and we worked with it there. We closed it at the end. But I'm also passing cout to this function, and so cout is going to be called OS when we get up here. That's its type. And we're also printing 1 to 10 to the terminal. Isn't that really cool? I think it's really fancy like that. We've never known like the type of cout. I learned that. Are there any questions about why that works? This function is doing the same thing for a file or for cout because they're similar types. Yes.
I have a question on the OS stream. Like, would it be like wrong to like call it OS stream, like pronouncing it, or is it actually just calling OS?
It's short for output file stream, so the O and F are separate. They're separate letters. It's an acronym at that point, yeah. So I'll call it OF stream. Just like I've heard people say cout, it's cout, common output. So, yeah, that's a good question though. That's how people pronounce these things. Any other questions? All right, let's see here. Let's do the opposite if we're good. If we're good with output file streams, let's do input file streams, right? The opposite. Let's have a way, like we have a file somewhere. Let's read the file and take stuff out of it. Let's extract information from a file that already exists, all right? So naturally, we're going to need to change the O to I. We're going to get input this time from a file, input file stream, all right? So we're getting a stream of data, ones and zeros in a river. given to us. All right, so we're going to make ifstream objects, and those also live in the fstream header, so we can just keep including fstream. It's right here, ifstream. Okay. There's one that does both. There's a where is it? There's just a normal fstream that does both input-output file streams at the same time, but we'll just do one or the other. This is fine. All right, so there's an ifstream, and you can do stuff. What do you think that it has? It functions similar to what? So just like OF streams function similar to cout, IF streams should function similar to cin. Yeah, there we go. Again, which means we get this guy. Give me stuff. Read in the opposite direction. Won't that be fun? So yeah, okay, that's this one. And so again, this is a new way to get input, right? Just like OF streams were another way to give output. IF streams are a way to get input from the user. So we know so far, there's a few ways to do it. Like we can use cin, or you can get a bunch of lines with getLine with cin still. Like cin was kind of the way we got input. Like that's getting input from the keyboard as the program is running. But we also know command line arguments, your argc, argv stuff. Like that's another way technically to give input to your program. And that happens before the program starts running, before you type enter and it starts. This is now a third option, right? We could read from a file instead and get information that way, okay? And so it's going to work very similar to like a combination of what we know from OFStream and like what we know from cin already. So every IF stream is a iStream. An iStream is what the type of cin is, and that is where we get all this stuff. That's where we get this give me stuff operator, extract, right? So yeah, cin is an iStream, and so is an IF stream, and that's where this operator comes from. That's why they both have it, okay? So let's see here. Do I want to do this? We'll do this next. So yeah, every cin is an iStream, and every IF stream is an iStream. That's why you can get stuff. And so let's make a program that reads a file. We've got a nice file ready to go, right, with a bunch of ints in it. Let's make a program that reads that file that we just wrote to, and we'll just like read the first 5 integers and do something with them. Like, well, maybe we'll sum them out or something. Sum them up, print them out. All right, print out that sum. Let's do it that way. So this will be with IF streams. Dun, dun, dun. Let me just do this from scratch. IF streams.cpp. So here we go. I'm going to include fstream because that's where ifstream lives as well. And then I'm going to open a file for reading. So I'm going to say ifstream, ifs is what I'll call mine. Why not? And you can do ifs.open, give it a file name, like my 1to10.txt. Like I'd like to read that file now, please. Or you can do the same idea of giving this in the constructor. So you could have also said, you could have done it this way. Just give it all at once, open it, and give it the file name. And then you also want to always remember to close your files, even if you open them for just reading by the time you're done. Do that when you're done with it. And yeah, here's how you do it. It's like pretend that the file is being typed to you, essentially. Pretend that IFS is like cin. You're reading the entire file. So int sum is 0. And then 4, I want to read 5 things, right? 5 ints. So for int I equals 0, I is less than 5, I plus plus. I just want to loop 5 times. And like get the next number out of the file, next num. And instead of saying cin, because it's not being typed to me, it's part of the file. It's read it out of the file, ifs into next num, all right? So it's getting the next integer out of the file, and then we'll add that into sum. All right, so that's the idea. And then we also want to eventually like print out the sum, and we're done with the file, but before we print out the sum, we don't need it anymore. So I don't need ifs anymore, and so it's a good idea to close it the second you're done with the file, so that other people in the operating system can look at it and use it. Okay, so yeah, that's the order. That should go there, not after the cout, because we didn't need ifs for this line, but that'll do it. That'll read 5 things from the file, very much similar to cin, right? Because the types are the same. And so we'll get the first 5 lines of this file that we have, right? Which will be the numbers 1 through 5. Right, we're getting the first 5 ints out of it. That's how we're reading it. And apparently the sum of 1 through 5 is 50, which I will trust. Okay. Any questions about this program? Not too bad, right? All right. let me make it fancy now. We'll do something kind of what you've done already with CN. Like I gave you this kind of syntax before. Let me explain why it works. It's going to take a lot of words. So here, let me get the red to go away first. So, all right, I've read the first 5 ints of the file, but like, how do I know up front, like, okay, there were 10 lines, or maybe if I ran that append program, there'd be even more lines. Like, how do I know, like, I want to read all the ints in the file and sum them all. How do I know when I'm done? That's the next question, right? I want to read everything. So how do we know when to stop reading? How do we know, like is it just going to fail or something? Like, I don't want to get an error. I just want to have it work. So here's the trick, all right? Every iStream object, just like ints, remember that ints like 42 is true and 0 is the only int that's false? There's something similar going on with iStreams, right? Cout as well as any file that you open. So every iStream object can be converted, if needed, into a bool, okay? And so that means you could do this. You could say if ifs, and this will just, like, we know it's a file, but it will be converted, if you use it like this, into a bool that is either truthy or falsy, right? It's true as long as the file is good to still be read from, all right? So that value represents whether your last read was fine, like the file is okay right now if it gives back true, okay? And ifstreams stop being true once you've reached or tried to read past the end of the file, right? So if we kept checking after every read, it would tell us. IFS would become false and tell us, oh no, that last read, no, it didn't actually work because we hit the end of the file. Does that make sense? So if it's, as long as this is true, we're good to keep going. The second it becomes false, your last read didn't work, okay? Because that hit the end. So that's one way to do it. You can also check for the .eof. There's a .eof method that's short for end of file. So that's here, .eof. It returns true if your file that you have, your file object, is hit the end of the file. All right, and that's the goal. So yeah, you can also check for that in an if statement, but I think it's less typing to do it this way. All right, and you can do something really cool if you keep this idea in mind. All right, so here's what you can do. Here's a really cool thing that I've shown you with CN already. You've done this in a lab, right? But let me try to tell you exactly why it's going to work, okay? So if you do this, you can say as a condition, right? We're going to do it like this, while IFS read into something. This as a condition will first do the read. It will try to read into this S variable, right? And then it will result, right? Just like every time you did like x equals 5, this resulted in whatever the right-hand side was. Like everything, if you put it even in a condition, it results in something. So this guy results in, after it does its work, it results in the left side. It results in just IFS, right? And then, if you put that in a condition like here, it will first read into S from the file, and then it will result in itself in IFS. And so it's like you said, while IFS at that point, and it will give back true if the read worked. And it will give back false and correctly stop the loop if the read failed. Does that make enough sense? It's a little weird. So that's something you did with CN already, same idea. But like this will read only valid things into S. It will stop the second there's no more things in the file to read, okay? So this is kind of how you think about this. While I can read from IFS into a variable called S, and it was a valid thing, do something with that S. That's how you're going to do it, okay? So that's the goal. This will eventually become false because of what I just said, and that means that that final read, it just didn't work, and it failed because it hit the end of the file, most likely, okay? So with that all in mind, here's just an example. Let's sum up every number in the file now, all right? And I'll prove to you, like, among other things, like the ifs.eof will give back true at that point, okay? So let's do that. What do I want to call this? So let's make, we got this first file that just sums the first 5 lines. Let's make a new file that sums everything in the file. All the lines, even if there's a million. I'll call it sum everything.cpp. All right, so again, you got to say what file you want to open. There it is. You'll start your sum, and then instead of doing it like this, we're going to do it a little bit differently. I'm going to say, like, I'm going to read a bunch of ints, and I'll call each int next num. That's the next number I've read. And here's how I'm going to do the loop. I'm going to say while I can read from IFS into next num, and it worked, right? So you're reading as the condition of your loop. So while I can read and it works, and this is guaranteed to the body only ever gets run, or only ever executes if the read was successful. That's what's about to happen. It's only ever going to work if the read was successful. And so if I'm in the body, that means the read worked on this file, and I have a valid value in next num. I'll add it in. That's the next number in the file. It wouldn't have run the body. It would have stopped. This would have become false if I tried to read past the end. So I'm not getting any garbage. Everything's glorious. All right? And so, yeah, we're going to get the correct sum. And the sum of all the numbers from 1 to 10, that's everything in this file, right, is, I think it was 55, right, if I remember correctly. But let's figure that out ourselves. Yeah, I've done that example so many times. It's like, I know it's 55. But that's going to read everything. Are there any questions about how you think about this? Like, while I can read from IFS into next num, and the result was good, do something with that value, with next num. I'll read all the valid ints in the file and stop once you hit the end. Is there a question? No, if you gave it like 1 to 10.6, if you gave it this exact file, you can give it sum everything.cpp. It will fail because it thinks it's about to read ints. It will try its best. It'll probably think it's a bunch of zeros, everything that's not an int. But you have to account for that. You have to know, like, oh, no, I should read a string and then some other things. So you have to be a bit more careful if your file doesn't contain just ints. Okay, yeah, that's a good question. All right. Yeah, and so by the time this is done, like this stops the loop, IFS becomes falsy at least, and what that means is we hit the end of the file. And so we can do .eof to show that. .eof will be true because we've hit the end of file. Cout ifs.eof, here's its result. And that should give back a true. And so it'll print 1 there. 1 for true. See that? So it did. That's another way that you could have checked it, something like that with an if statement, but you have to check after the read. So it's just cleaner to do it this way, honestly. It's pretty cool. So this is only ever going to run if the read was successful. All right? That's how you can get to everything in a file. All right? Any questions about this? Or I'll give you something to try. Yeah. Yeah, just the default way that C++ prints Boolean values, because this is giving back true or false. It's 1 for true, 0 for false. Yeah. Very good, very good. Okay. We have many ideas. Here is, let's see here. Here's a question for you. I want you to try this. Okay. I'd like you to attempt to write a program that does the following. I would like you to write a program that repeatedly gets a line from the user and then appends that line to some file of your choosing. All right. So here is my append example. I'll give you plenty of minutes to do this. This is just going to be the last thing we do today. A very nice, easy lecture because I have many things to announce anyways. Here's my append code. Here's the relevant append code for my example. I'd like you to take this and change it. All right. Make a file of a name of your choosing. Call it whatever. But you got to open the file in append mode for sure. It's got to be iOS base, right? iOS base : app and help each other. So get on the server. I'd like you to have your program work like this. Like you give the user a prompt, and like you can just have them typing lines. You're going to call getLine or something to get a string. And so like the user types hello, enter, and then what should happen is, or let's do hi. The user types hi and then enter. It should go to your file that you've opened for appending and add hi to the end. If it's the first thing, it'll just that's the file. And then just keep asking the user for stuff. Hi, mom. They type enter now. It should type mom to the file. Then blah. It's just like a log of things. Okay, it's just keeping track of whatever the user's ever typed. Blah. It's like a comment section of like a social media website. It's essentially what you're programming right now. And then let's say if they ever type Q, that's when you're done. Like that'll stop the program. So look into that. So you're going to use getLine, you're going to use opening files, OF streams and stuff. And then if you rerun the program now, because you're opening it in append mode, and they type like hello, and then Q to quit, then it should add hello to the bottom down here. Does that make sense? So that's what I want you to try using my code as an example. I'll give you plenty of time. But please do this and ask me questions. I want everybody to get it. And it's just essentially a comment section of like a website. That's what you're programming right now, because it's saving it for later. Everybody can come and look at it. So yeah, give that a try for a few minutes, and then I'll show you how I might think about this, and I'll show you my implementation. Yeah, I'll give you plenty of time. You're gonna have to loop, right? Loop with a prompt, a little arrow or something. Type your comment here. Type it on the server so you can run it. What was that? Give you 3 more minutes to try it. I'll show you my answer. Yeah. Be able to rerun it a few times and then go to your file, whatever name you gave it. It should have stuff. I'll show you my answer in 2 minutes. But try to get it right on yourself. Alright, that's my timer. Did we get it? Almost there. So yeah, keep working. But here, let's come back and I will do my best to explain how I will think about the problem and how I might solve it. Alright? Look away if you want to keep doing it yourself. So I'll call this file getLine and append, because that's kind of what it's doing, right? I'll call this that, and I guess I'll steal a lot of my append code. Steal a lot of that code there. And let's see, I'll open it once and for all using the constructor this time, why not? So output file stream, give it some name. Maybe I'll call this file out.txt or something. I think that would work. And I want to open it up in append mode for sure. Append mode. And I always want to close my file. Can't forget that. But then what do we do in between now is the question. All right. So I gotta give a prompt a bunch of times in a loop called getLine to get whatever the user gives me, because they might like give me a whole sentence worth of stuff. And then watch out for Q, because that needs to stop the loop. All right, and not actually add to the file. So kind of like, I'm not sure when this is done, so like wild truth. I want an infinite loop potentially if the user never wants to type Q. So all right, let's get a line from the user with getLine. Let's tell the user what we want first. Enter a line. Enter a line. Enter your comment or whatever. And then we'll call getLine on CN reading into line. Now you know exactly how getLine is implemented, don't you? You can make your own getLine if you try hard enough. All it's doing is, the type of CN. This is being taken as a reference, right? So you can mess with this line variable. Like, the full story now to a lot of things, which is cool. I got a line from the user. If it was Q, it means I'm done. I don't actually want to type this out to the file. So if the line was Q, that was all it was, then we're done. We can break out. Otherwise, if we're still here, this was a line I want. It was a valid comment. I want to add it to the file. All right, add it to the end. Just by opening it in append mode, we're good to go. It's called OFS, and I will shove that line into there and break it, because like by default, getLine gets rid of the \n for us. So I got to add it back in. Okay, so add this line to the file. And that's pretty much it. Close the file, but that's the code. Let's see, so that should do it. And let's compile and run. Dash o, get line and append. And I've called this file out.txt. Slash get line and append, boop. Enter line, I don't know what were my examples, hi mom and blah. Hi mom, blah, and then Q to quit. And then you see that it made a brand new out.txt file for me. So let's look at that one. What does it get? There it is, hi mom and blah. And so if I rerun the program, it should keep that stuff there. I can add more. Hello. Hello. It was getLine, so I could have multiple things. Hello, comma, space, world, exclamation point. Well, that's fine too. And Q to quit. And then if I have it refresh the file, there it is. It's all at the end. So this is like it's comments that can't be deleted, essentially, like a logbook. So yeah, that's how I would think about the problem. That's how I might implement it. Are there any questions about that? That's a fun little example, I think. But yeah, I think that's all that I wanted to say for the day. Do we have any questions about anything I talked about before I switch gears into other things? Because I got a lot to say, don't I? So that's the first part of files. Good, fun stuff. Let's go and talk about your next lab. That'll be due next week. Lab 6. It's time. Ooh, new features. This is the one lab in this class where you have to do the other one to get credit on this one, because this is rational numbers again. So you're gonna like copy and paste the new stuff. But we're translating it from functions to classes. Okay, so this is a classes lab. So you definitely get the rational numbers functions one working, because you're gonna copy in a lot of your work. Okay, it's the one lab in the class where we have to do it that way. Because it's really cool to see like the new stuff that we can do. This is called starter code 4006. All right, so here are all the files that you get: a rational numbers library again, and a testing file. Okay, and so what you're going to do is you're going to take pretty much what we did, a lot of what we did in the rational numbers library, just using functions, and make it classy. Make it using classes instead. All right, so we're going to have a rational number class now. And that's going to package together in one nice place, right? Your numerator and your denominator. That was dumb that we were doing it separately with the functions. We didn't know how to make it cool yet. But now we can, all right? So let's just look at rationals.h to see the new stuff. Here is every rational number object looks like this. What does it have? What kind of data does it have? Every rational number has a numerator and a denominator inside of it. That's so much better, right? So much better. So there's that. And then we have a constructor for a rational number. So like give it a numerator and a denominator at the start. We have a two pretty string method now. So you're just going to copy and paste pretty much what you've done before. It's going to be a const method, right? Because it's not supposed to change anything. And it will give back a string. We have a multiplication operator now because we know how to do that. It's const again because it doesn't mess with our own stuff. It gives back a brand new rational number. And then we're also going to include like the new thing. We're going to translate everything else we had to classes, and like the one new thing, right, is going to be this plus operator, which that's what you didn't do last time. So a little bit of extra work. And then, finally, we're going to have a private method. Simplify is just going to be for us. The user doesn't even need to know. They don't get to use simplify. Only we, the people who are making the rational number class, get to use simplify. Okay. So that's how that's going to work. Just a helper for us, not for the user to call by themselves. Right? So that's what a rational number looks like in class form. That's like a cool way to do it. Does that make sense? Can we understand everything that's written here? We're going to implement it all right? So yeah, that's going to have the declaration of everything in that file, and you're going to implement all those methods in rationals.cpp so that like you're good to go. Everybody can include your library and do cool stuff with it. All right, so here is the CPP file. I've given you a lot of starts to all these things, so like the constructor, right, to set the numerator and the denominator of your brand new rational object to like whatever the user just passed, 1 and 2 or something, I don't know. And yeah, you're good to go there. That's how you implement that. To pretty string, you can pretty much copy and paste from your old implementation. The one new thing is the simplification is not going to happen in to pretty string because it's const. It can't mess with the member variables. So where we're going to simplify instead is in the constructor. All right. So the constructor's job is to set the numerator, set the non-member variable, and then call simplify. All right. simplifying yourself. Okay, and the way to do that, there's no like me dot simplify. You can't really do it that way. The way that you do it to call a method on yourself is you just say the name of the method by itself. That's going to call it on you. Even though it looks like a function call, simplify is a method call to you. All right, because that's what it's called. Here's simplify. It's a method on yourself. So just call it like a function, essentially. Calling it on you. That's how that works. And so that's what you're going to do. Those are your 3 pieces in the constructor. And then two pretty strings should make sense. Like it's already been simplified, so all that you have to do is return the string version of the numerator and the denominator member variables that live within you. Okay, so it's very similar. Pretty much a copy and paste though, except for the simplification. And then we've got this operator star now, so that's your multiplication of rational numbers, which you already had an implementation of. You're just going to copy it into here. Right? So you have your own numer and denom, and you're multiplying that by some other rational number's numer and denom, other dot numer, other dot denom, okay, because that's where it lives. It's now inside of the rational number. And then you can return a brand new rational number. One way to do it is to like call the constructor like this here. You can return a call to the constructor, and that will return a brand new rational number object. And that will just like automatically simplify it for you too, because right, it's going to do that in the constructor. That's pretty cool. So yeah, just remember like numer2 from the other examples, like other.numer now, okay? Because that's where it lives. That's where it lives in every rational number object. Okay, there's that one. Just yell at me if you guys have any questions. I'm just going through it. So there's that one. And then let's see. Simplify is back down here still. Simplify is exactly the same pretty much. It's just like you're not being passed anything by reference because it's your member variables that you're messing with now. Okay, your numer, your denom. We don't need anything. They are already your member variables. Just use them. They already exist. Here's your GCD helper function. Rational simplify is pretty much copy and paste what you did last time. Okay, it should be exactly the same. All right, just we don't need any parameters this time because they're our member variables. All right, and the one new thing is the plus, adding 2 rational numbers together. Okay, that's a little bit more complicated than multiplying, right? Because to add 2 fractions, you have to find a common denominator. So here's the trick, right? To do plus a over b plus c over d, you gotta do it this way, right? bd is your common denominator, and like it becomes, this is your final answer, right? You have to then like compute that and simplify it. So this becomes your numer, this becomes your denom, and then you'll simplify it. Okay, does that make sense? So that's gonna be your addition. Not too horrible once you just read it off, right? And yeah, I've given you a bunch of tests. So here's kind of like here's me using rational numbers. Whee! That is in the test.cpp file that uses the library. Here it is including it, and I've got a few tests for you. All right, so here is a test for like the constructor, and the constructor should automatically simplify things, right? Implicitly, it's also a test of pretty string. You have to have pretty string working to get any of these working. So like here's a numerator and denom. I'm constructing a rational number with numerator of 2 and a denominator of -44, and so your constructor should simplify it, some things, and then asking for that number's pre-version as a string should have been that. Okay, so pretty much the same as before, just with we're using objects this time. It's pretty cool. All right, and so here I am using the star finally to just multiply rational numbers. That's beautiful. So these 2 rational numbers, multiply them. It should have simplified the result as well. And so the final answer, the pretty string for the result rational number should be 1/44. And then I got the same kind of thing going on with a plus test. Like these 2 things added together, apparently after simplification is that. Okay, as a pretty string. All right, so that's pretty much everything that I gave you for your lab. Does that part make sense, these tests? So get those passing. Question? Yeah. Mm-hmm. So which one? No printing happens. It's just assert true is being called. Assert true does print stuff. Yes, it prints passed or failed, but none of this code prints anything. It's just doing operations inside of the rational numbers. Is that your question?
Yeah, like I understand that, like at the end, like it is supposed to like print out like the simplified version, and like it also prints out like.
Oh, 2 pretty string. Are you asking what 2 pretty string should do?
Yeah.
2 pretty string returns a string. It does not print anything. So it's giving back a string, but it's not printing that string to the output screen. Does that make sense? Yeah, so I'm checking that what your 2 pretty string gives back is it's supposed to return a string. Yeah, where is that? It's going to give back a string, right? It's not void, it's given back a string, and that string that you should get back for this particular example is this one. Okay? So you could have, like, normally, like in a normal program, you'd be like cout result.toPrettyString. But in a test, we're just checking like the next statement, kind of. Okay? Yeah. Good. So yeah, that's going to be those tests. And yeah, get those to pass, look like that. And then the final step, final piece of the puzzle is to write some of your own tests. All right, I'd like you to write 2 more tests, please. Come up with some wild example idea. Maybe you can have like 3 rational numbers, like you can multiply the first 2 and like add the third one to the result or something, like a combination test. That would be a good one. But come up with 2 wild ideas, create scenarios, run them in your mind, and make 2 more tests. So in total, the autograder wants to see passed 5 times, right? 3 from mine, 2 from yours. Okay, so that's going to be your output, and that'll give you practice writing tests and getting more confident in your implementation. So yeah, I think that's all that I wanted to say there. Any questions about the lab? Yeah.
Actually, how come you have to have like the comma and then like you have like the unsimplified like
These words?
like in the code, like what we were just talking about, like where is it like inside a search true and like the
Yeah, this is just a string that's going to be printed as part of the test. So it could be anything. I could have typed anything here. But, it's just for the person who's reading the test results. It's whatever you want to be there. So that's the string that I put.
because I was wondering like how come you have like the comma and then the 2 over -44 times.
Where do you see that? This one? So yeah, there's 2 arguments to assert true. So go back to the lecture where I introduced assert true. It takes the thing you want to check, the Boolean. That's a Boolean. And then the second thing is this description of the test, and that will be output next to passed or failed. Okay, yeah, so go back to my implementation of assert true. Like I told you what, here's assert true. Like go stare at that for a while, I think is my answer. Yeah, so yeah, I think that's that one. Any other questions? Yeah. Like you're saying you want to make some new methods for yourself?
No, like how you put simplify in private. Can I use that in the method?
Yes, you can use them because you're the implementer. You get to see everything. So you can call simplify in any of these. Or actually, no, you can't. You can only call simplify in the constructor because all of these are const. Simplify messes with stuff. So that's a good point. Now you can't call simplify except in the constructor because of the const limitation. So that's the reason I did it that way. But yeah, if the const wasn't there, you totally could. That's the one thing that's keeping you from doing it. Yeah, that's the big deal. That's the big reason. Yeah. We don't want the user to simplify. We should be doing it for him. That's the goal. Yeah. So yeah, the 2 things that you're turning in are rationals.cpp and test.cpp. I'm testing you on the original rationals.h, so don't try to add more methods or anything. All right. So that's got to look exactly like this. Can't touch rationals.h. All right. So yeah, I think that's all I want to say about lab 6, and pretty much take what you had, convert it to classes. All right. We're good. So that's that one. And now I need to talk about your test, right? We are in week 10, so exactly 2 weeks from now, week 12 is when I promised our next midterm, all right? So here, let's release the info page and the extra credit assignment page. You should be able to see it now. Whee! So, just due to the way that dates work, our midterm is going to be on Halloween. I'm so sorry. But at least it'll be over with, and then you can go party, right? So here is the information about the test. It'll be in class. You got to come here or take it at the testing center if you have a DSPNS, whatever. It will be here on Halloween, all right? So you're going to have an hour and a half to take it at the start of class, just like we did last time, right? That's how it's going to be. Here are the topics. Obviously, everything builds on top of itself, so I can't be like, oh, it's nothing from the first midterm, but of course, like, there's going to be loops and stuff, so like I have to say it's pretty much cumulative. That's how the class works, but I'll try to cover and focus on the things from after the first midterm. Okay, so like these new things you should be very comfortable with. Okay, so there's that. And yeah, just like last time, it's got the same fill in the blank questions, coding questions. You should like be on the server, remember how to copy and paste, right? So you can test things yourself. And here's some sample questions. Okay, so yeah, did the logistics make sense? It's going to be very similar to the first one. Okay, so there's that. And yeah, with every new test, I like to give a new extra credit assignment. Just like last time, if you would like to make a review video, you can do it all over again. All right, so this one is again worth up to 2.5% of extra credit. It has to be due, or the date that it's due is midnight before the test comes out, so I guess it's midnight on the 30th. I think I might have messed that up, actually. Let me fix that. Midnight on the 30th, then, right? Let me make sure that's how it is. No, yeah, I did mess it up. Here. Midnight on the 30th, 11:59 p.m., no later. Okay? So get in early. But yeah, it's worth up to 2.5%. And yeah, just like last time, here are your requirements. Just like make a bunch of examples of stuff that might appear on the exam. Go crazy. Pretend to be a little teacher, probably. Like that would be the best way. Like make some slides, make some example code, talk about what you're doing. But just like this is a review stuff. If you want half the extra credit, make a 10-minute video. If you want the full 2.5, make a 20-minute video. And just remember, as usual, to make something new. It's extra credit. It's got to be extra. So you can't just read off your lab that you've already completed. That's not extra. You can't read off the slides that I've took time to make myself. That's not extra, right? You got to make your own stuff. Okay. So yeah, just let me know if you have any questions about whether or not what you're doing is good enough. I will tell you immediately. And yeah, I can help you if you're having trouble recording, stuff like that. But yeah, that's the due date, and that is the extra credit assignment. Any questions about that? So that's the midterm. You know when it's going to be now, 2 weeks. And that's that one. So just come here and you'll click it again to take the exam. And I think that's all that I wanted to say. Finally, a lot of stuff. Any questions about anything at all? All right, the time is all yours now. Do what you need to do.